Everything you're about to see is real, and one of these discoveries should not exist at all. The universe isn't just vast and mysterious, it's actively breaking the rules we thought governed it. Every time we point a new telescope at the sky, we don't just find stars or planets, we find anomalies. Cosmic glitches that force us to question reality itself. Today, we're exploring 8 discoveries so extreme they sound like science fiction, but they are very real. From structures larger than anything should be, to stars that defy time itself, this is a journey to the edge of what's possible. Let's start with something unimaginably big. Galaxies are massive islands of stars. The Milky Way alone is about 100,000 light-years wide. But astronomers found structures that make galaxies look microscopic. They discovered enormous walls of galaxies, cosmic filaments stretching hundreds of millions of light-years. One of the most famous is the Hercules Corona Borealis. Great Wall. It is over 10 billion light-years away and far larger than anything our models say should exist. According to cosmology, matter from the Big Bang should clump only up to a certain size. Nothing should exceed about 1.2 billion light-years across. Yet these structures are many times larger. They challenge the foundations of how matter should organize itself. Now let's zoom in from the impossibly large to the impossibly old. Stars form from collapsing clouds of gas. Early stars contain mostly hydrogen and helium. Later generations contain heavier elements. By reading a star's chemistry, we can estimate its age. But astronomers found stars that appear older than the galaxies they live in. Their chemical makeup suggests they formed before their host galaxies fully existed. It's like finding an ancient artifact inside a structure that shouldn't be old enough to contain it. This suggests star formation began earlier and more chaotically than expected. The first building blocks of galaxies may have existed long before galaxies themselves. Now we move to a place where time starts to fail. At the centers of most galaxies lie supermassive black holes, millions or billions of times more massive than the Sun. Einstein predicted that massive objects warp spacetime. Near black holes, this effect becomes extreme. As light climbs out of intense gravity, it loses energy, its wavelength stretches. Time appears to slow. To a distant observer, objects near the event horizon seem to freeze. The final light never fully arrives. We can't watch a clock stop. But we do see light from matter behaving exactly this way. Time isn't fixed. It can bend, stretch, and nearly stop. Now to one of the biggest mysteries in science, dark matter. Invisible, undetectable, directly, yet essential for holding galaxies together. Without it, galaxies should fly apart as they spin. Yet astronomers found rare galaxies that appear to contain little or no dark matter. Their stars move exactly as visible mass predicts. These ghost galaxies should not exist. Either they formed in ways we don't understand, or our understanding of gravity itself is incomplete. Next, a rule that seems unbreakable. Nothing escapes a black hole, but just outside the event horizon, chaos reigns. Matter forms a superheated accretion disk. Magnetic forces launch colossal jets at nearly the speed of light. These jets stretch millions of light-years. They trigger star formation, clear gas, and reshape entire galaxy clusters. Black holes are not just destroyers, they are architects of the cosmos. Now let's travel back to the universe's first light. About 380,000 years after the Big Bang, atoms formed. Light was finally free to travel. That light still exists today as the cosmic microwave background. At first, it looked perfectly uniform. Then we saw tiny temperature differences. These variations are incredibly small, but they became the seeds of all structure. Slightly denser regions formed galaxies and clusters. Less dense regions became vast cosmic voids. From these tiny fluctuations, everything grew. Zoom out far enough, and the universe looks foamy. A vast cosmic web of filaments and voids. Galaxies line up along invisible strands. Voids stretch hundreds of millions of light-years. Space is not smooth or random. It is structured, uneven, and interconnected. Every new telescope forces us to rewrite our models. Hubble revealed accelerating expansion. James Webb is finding massive galaxies far earlier than expected. These aren't small adjustments, they are revolutions. The universe isn't just stranger than we imagine, it's stranger than we can imagine. These discoveries are clues. They tell us our models are incomplete, And if all of this already breaks our understanding, what happens when we finally see what's still hidden? The universe's greatest surprises are still waiting. If you love exploring cosmic mysteries that challenge reality, follow Trendburst Studio. We'll keep bringing you the stories that break the universe.